This is the second mini lecture for section 3.5 of the textbook. Okay, so in the last mini lecture we talked about the base 4 system. Now let's talk about the base 5 system. Okay, just as the base 10 system is based on powers of 10, and the base 4 system is based on powers of 4, the base 5 system is based on powers of 5. Okay, and it uses 5 digits, 0, 1, 2, 3, and 4. In this system, the digit 5 is not used. Instead, we represent the number 5 by a 1, 0, because 1, 0 base 5 would be 1, 5, and 0 ones. Okay, so let's try to write the number 304 base 5 in base 10 notation. And I'm going to draw a picture of it first. I don't really have to do that, but I think it's helpful to see it. Okay, so now we're talking about 5 by 5 mats. And we need 3 of those. Three mats is 0 strips and 4 units. Okay, if I add these up, see it's 25, 50, 75, plus 4 is 79. Okay, but I could also just use expanded notation. 3 times 5 squared plus 0 times 5 plus 4. That's 75 plus 0 plus 4 is 79. And of course, when I write 79 without the little base by it, that means base 10. But just for clarity, I can also say 79 base 10. And whenever we write one of our own numerals, it's kind of like there's a little invisible 10 by it. So let's try to go the other direction. Let's write the number 107 in base 5. And I'm going to do this one with pictures. And because the number is small enough. Okay, so I just start adding in mats. Okay, one mat is 25, and a second mat is 50. Third mat. Gets us up to 75. And the fourth mat gets us up to 100. And that's as far as we can go with the mats. Of course, I knew I'd have to stop at 4 no matter what, because I'm not allowed to have more than 4 of anything in the base 5 system. Just as in the base 10 system, we can't have more than 9 of anything. Okay, so we have 4 mats. That's 100. If I add in a strip, we get up to 105. Now the second strip would bring us up to 110. So that's too large. So we just start adding in units. So one unit gets us up to 106. The second one gets us up to 107. So you've got 4, 1, 2. This is 412 base 5. Okay, in the next example, we're going to do the same thing, but this number is too large to be able to use mats for. You can only have up to 4 mats, which is 100, and this is much larger than that. So I'm going to begin by listing the powers of 5. 5 to the 0 is 1, 5 to the 1 is 5, 5 squared is 25, 5 to the third power, 5 times 5 times 5 is 125. 5 to the fourth power, 5 times 5 times 5 times 5. If I work that out, that's 625. And you keep going that direction. And clearly 125 is going to be where we want to start. So I begin by dividing that into 279. Goes in there twice. It's 29 left over. Okay, so I need two 125s. Now I want to know how many 25s do I need. So I divide 25 into the leftover. Goes in there once with the remainder of 2. Now I need to know how many 5s, and I can see there's not any, but just to help me keep the place, I'll go ahead and perform the division. 5 goes into 2 0 times, with 2 left over. So I need 2 125s, 1 25, 0 5s, and 2 1s. And what I have here again, it's 2 times 5 cubed plus 1 times 5 squared plus 0 times 5 plus 2, which is 2, 1, 0, 2, base 5. Okay, now on the homework, you will be given problems involving base 5 and base 6. There won't be any base 4 problems on there. There are base 6. And I'll just remind you that for base 6, you'd have places worth successive powers of 6. You're going to have a 6 to the 0 place, which is 1. 6 to the 1 is 6. 6 squared is 36. 6 cubed is 216, and so on. Okay, so you use these powers of 6, just like we've been using 5s and 4s. Okay, if you want to use pictures to solve some of these, which I recommend, the book doesn't ask you to do that, but I think it's a good idea. The mats are 6 by 6 mats. Okay, they're worth 36 each. The strips will be 6 units long. And then, of course, the units are units. So if you want to imagine manipulatives for this numeration system, that's what they would look like.